This video will introduce you to Ohm's law and its applicability to electronics. You'll learn about the history of Ohm's law and how it works. Ohm's law was developed in 1826 by Georg Simon Ohm. It claims that, under constant temperature and other physical conditions, the amount of electric current flowing through a conductor is directly proportional to the voltage and inversely proportional to its resistance. According to the law of electricity, the direct current's intensity is directly related to the potential difference and inversely proportional to the circuit's resistance. Thus, Ohm's law establishes the relationship between voltage, V, and current, I, across two ends of a conductor where resistance, R, provided by the conductor to allow the flow of current is constant. The mathematical relationship is described with the following formula. V is equal to I multiplied by R. We can use the formula into more variations and they are: I is equal to V by R and R is equal to V by I. There are various uses and applications of Ohm's law. Following are some examples of how Ohm's law is used. In electrical circuits, the value of resistors required for the proper functioning of the circuit is derived by using Ohm's law. Most of the branches that use electrical use Ohm's law. It is inapplicable to semiconductors. Further, Ohm's law applies to finding the current flow in a circuit where we can easily measure the voltage, V, across a known resistor. Ohm's law maintains the desired voltage drop across the electrical components. The value of a circuit's voltage, resistance, or current can be determined using Ohm's law, which estimates power usage. And in DC ammeters and other DC shunts, the current is diverted using Ohm's law. Here are Ohm's law units that are used to derive the results. Material science and electromagnetics are the fields where you will see the usage of Ohm's law in vector form. This is how Ohm's law is shown as, in vector form. J is equal to sigma E, where J is the current density, which is the vector equivalent of the current. E is an electric field, the vector equivalent of potential difference, and sigma is conductivity, which is the reciprocal of resistivity. J is equal to E stands for electrical conductivity, where E is the electric field and J is the current density, and this is the microscopic form of Ohm's law. The experiment below demonstrates Ohm's law. The step-by-step procedure is mentioned in the points below. At first, the key, K, is closed, and the rheostat is adjusted to get the ammeter, A, and voltmeter, V, minimum reading. Gradually the current in the circuit is increased by moving the sliding terminal of the rheostat. While the process is ongoing, the current flowing in the circuit and the corresponding value of potential difference across the resistance wire are recorded. This way, different sets of values of voltage and current are obtained. For each set of values of V and I, the ratio of V by I is calculated. When you calculate the ratio V by I for each case, you will notice that it is almost the same. So V by I is equal to R, which is a constant. The chart below depicts the relationship between voltage, current, and resistance. Suppose we are tripling and doubling the voltage. In that case, that results in doubling and tripling the circuit's current, that is if the voltage is 3V and the current is 6 ohms, the current will be 0.5 A. Likewise, suppose we double the overall resistance. In that case, it breaks down the circuit's current into half. That is 3V and the current is 12 ohms. The current will be 0.25 A. Further, the relationship between voltage and current is V directly proportional to I. Some limitations are involved while practically using Ohm's law to derive the results of some equations. Some of them are as follows. The law is not applied to unilateral electrical elements like diodes and transistors as they permit the current to flow in a particular direction. In the case of nonlinear electrical elements with parameters like capacitance, resistance, and others, the ratio between voltage and current won't be constant. It is because time makes it difficult to use Ohm's law. With that we come to an end to today's video, and to read more on Ohm's law, check out the link in the description as well as check out our website at www.getmyuni.com.